Okay, let's have a class, and we're gonna do a final exam lab review. Okay, so here's something. We have total is 200 points. Is that right? So this is A. That is solid A. If this is I minus, okay, that is encoding everything, plus you bonus points of the lab notebook. And the lab notebook I already checked once in the midterm exam. In the final exam time, you're going to bring it. Okay, when is the final exam? Thursday after Thanksgiving. Okay? Why I do that? Usually the Tuesday you will not do very well because your mind is still with turkey breast. So I usually do is on Thursday, the previous results will be much better than the exam have on Tuesday. And also on Thursday, you're going to clean your personal tray, okay? So that's the overview picture. In your e-campus, what we're going to put is basically is your unknown number 1, unknown number 2, dilution quiz, midterm exam, final exam, and also your attendance points, okay? The bonus points for the lab, I cannot put there because they not allow us to add it. You need to add a percentage there. What I'm saying is that if you need it, if you already have 180, then I'm not going to even check your bonus points. Anywhere below that, I'll go ahead to check the bonus points. As long as your total points is above this, is A. Your total points is between 135 is 180 is A minus. Then below that we'll just do B and C. I don't think anybody is worse than B in the history because it's only 1 credit hours. Okay. So that's what we very briefly talk about. What we gonna do. I will talk about the lecture exam. The grading or something during the final exam of the lab, because that everybody will be here. Okay, then I talk a little bit before you do the final exam of the lab. I'll talk about the lecture exam, what it looks like, how the grading system gonna be looks like. So let's do a review. So this will be the final lab exam review. Okay, the first thing is what we did already. Microbial analysis on foods. Okay, lots of you did a different products. You have your results is different. Because it's from the commercial. Some of you, the hot dog is very clean. Some of you get a different results. Some of you are lots of bacteria. Let's say this is a group 2 from the tomato, looks good. Okay, so the results is pending because you recording whatever you have. But I'm going to tell you what we're going to test you in the exam, what question will be looks like. Okay, the first one, we had a hot dog. Basically, is calculation. Okay, remember how we did the hot dog? We put them in the sample bag, and we shake 30 seconds. We add how many? Is that 100 ml or 50 ml? Okay, we add 100 ml, 0.1% nutrient broth, and shake 30 seconds. Let's say you have other place with the final dilution factor is 10 to the power of 3, and you get Let's just give an example. 30 CFU there. Okay, let's say. So first of all, what is CFU? Colony forming unit. Okay, what is the legal zone? That is 30 among 300. Let's say I have a results. In the 10 to the power of 3, I get 30 CFU. What I want to calculate on the hot dog surface is the log CFU per square centimeter. And I already been did the research and we already tested it. The hot dog surface approximately 50 square centimeter. So what's the calculation for that? That is 30 multiplied by 10 to the power of 3. Okay, that means how many bacteria CFU per ml. Then how many volume there? That is 100. That means that's a bacteria in the whole bag. But they are coming out from the surface of the hot dog. What's the surface of the hot dog? Is 50 cm square. So if you do this, how many we get? 60 multiplied by 10 to the 3. That equals 6 multiplied by 10 to the 4 CFU per square centimeter. If you want to change to the log, this approximately 4.7 log 10 CFU per square centimeter. That is how we're going to do the hot dog. Okay, let's say second one. You can have ground beef. How we did the ground beef, do you remember? In the future the bag, we add a chunk of the ground beef. We add 25 grams. And then we are adding 100 ml 0.1% nutrient loss. And we do the stomach or homogenizer. We call it a stomach or homogenizer for 30 seconds. We want to count it here is log CFU per gram. So then how we do it? Let's assuming you have the same results. It's right here. This is the place you have. And then with this results. So how you do it? It's 30 multiplied by 10 to the power of 3. You had 100 ml nutrient plus. You had 25 grams of the ground beef. Once you homogenize, there's a whole system. So how are you going to calculate? This will be 25 add 100. And where the whole bacteria comes from? Comes from the ground beef. So you divide it by 25. What we get? This whole thing equals 5. So we get 150 multiplied by 10 to the power of 3. We get 1.5 multiplied by 10 to the power of 5. That means approximately 5.2 log 10 CFU per gram. Okay? So that's how we do ground beef. That's a hot dog, that's a ground beef. Okay, C. We have a tomato. How we did the tomato? We put one tomato there. Remember? And we shake 30 seconds, massage 30 seconds, and we also add 50 ml, 0.1% nutrient broth. This year, the tomato is very small. It's a cherry tomato. So how we do the calculation? We want to see CFU per tomato. Because we didn't weigh a gram of the tomato. So how to do it? We still use that. Z equals 10 to the power of 3. I should write 30 first, okay? Z equals 30 multiplied by 10 power of 3 multiplied by 50. Because that's everything is coming from the tomato. So this means 150 multiplied by 10 to the power of 3, Z equals 1.5 multiplied by 10 to the power of 5, CFU per tomato. And that equals approximately 5.2 log 10 CFU per tomato. So that's how we calculate the tomato. Okay, how about chicken? That's chicken. I should say chicken carcass. So I put a whole chicken there, remember? And then we put a poultry bag. We will add 200 ml of the liquid solution. But for the poultry, because it's very large, so what we do? We usually do CFU per ml rinsing nates. So that means it's easy. If this is the number, that's equals 30 multiplied by 10 to the power of 3 equals 3 multiplied by 10 to the power of the 4 CFU per ml rinse nates. And that is approximately 4.3 log 10 CFU ml per rinse nates. That is how we calculated all these. Okay? This will be in the exam to let you do the calculation. So if we want to review one more time, hot dog, because there's lots of them coming from the hot dog. So we always first do is very straightforward. The colony multiplied by the final dilution, then multiplied by the volume of the solution. And where are they? They all coming from the hot dog, but come from the hot dog surface. So the hot dog surface is 50 square centimeter. That is gives you square centimeter. This you can using calculator to transfer to the log. Ground beef. The tricky thing is that ground beef and the solution is homogenized. So 25 grams of the beef with 100 ml nutrient broth, they're homogenized. So they're the whole system. And in the physics, you also know gram equals ml. So you add up them together. That's why the above is 125. And where the bacteria comes from? Come from the ground beef. So you divide it by 25. So that gives you CFU per ml. Tomato, they're all coming from the tomato, and tomato is very small, so we cannot measure the surface diameter or something. We do is CFU per tomato. So very simple, CFU, dilution factor, how many solutions there is 50. They're all coming from the tomato surface, so it's per tomato. chicken carcasses, it's huge. We cannot do the weight or something. So we just do CFU per ml ring states. That is simple, is CFU multiplied by the dilution factor. Okay, so this is very important. The first thing what we will test you in the final exam is the calculation of these bacteria on the foods. Okay, the second one we talk about is APCs, coliform, and also we talk about the ECC in pound water. Okay, the first question first. What is APC? That is called aerobic plate counts. So what is ECC? That's E. coli. Basically generic E. coli. Okay, what is TCC? Total coliform. Now, I look at your plates already. You basically get what? APC, a lot. In the petrofilm, what you have the pound water is basically coliform. And we didn't see any of you get an E. coli, and that's good. That means our pound water near the WVU doesn't have any contamination with fecal, with animal human poop. Otherwise, you get a problem. So that's not bad. So, what we can see is, what is APC? You see APC like that? That's APC. Okay, then you have another plate, looks like this, a petrofilm. We have a circle there. You see these dots? That's coliform. And then what is the fecal coliform? Oh, what is the generic E. coli? And I said that if you see something like this, and then you have a gas bubble. Although we didn't have it. So this is gas bubble. With a purple colony. And this is E. coli. And what is total coliform? They add up together. Is total coliform. Okay, now what is fecal coliform? They grow 44.5 degrees Celsius. What is the regulation of the generic E. coli and the coliform in our drinking water? Zero tolerance. Okay, so that's our second one. We just do a review. Third. Plates from you guys. Looks good. What you find there? Modes and yeast, which is fungi. I already take a picture. That could be in the exam. That's really good. What the modes and the yeast we talk about? So we talk about, say, the pathogenic modes. So what are the possibility of the pathogenic modes right here? Do you remember? What are the names for that? Aspergillus. What is the B? Rosatus. What's C? Penicillin. Okay, I have a question. If I want the testing, the the modes here, using the methods we learned in the lab, which dye we should use? It's called lactophenol cotton blue. Is that right? That's a dye we should use. Then go ahead to look at your morphology in your fact sheets, or you take a picture already. Plus here we are using 40x microscope lens, objective lens. And do not forget, lots of you, almost all of you, is attending Amy's guest lecture. There is an extra points question in his last slides. Remember, in her last slides? You should study for that. We had fun in their lab, but we're going to have one question to ask you. Okay? So don't forget about it. So I want to say this is also we are adding Amy's last slides question. Okay? So basically we end up here is what we did in the lab. But I said final exam theoretically will be difficult than the exam 1. And we say midterm exam. Why? Because remember we had a big biochemistry test. Is that right? So we're going to review the biochemistry test. So there's going to be a big chunk, a huge chunk, is for biochemical test. Okay, what we did, I want you guys to have some reaction. Do you remember what we did in the first day? The first is urea test. So how we did it? And you guys get urea. And if bacteria has ureas, it will break down, become ammonia, and also carbon dioxide. Okay, how do you know it's urea test positive? Because it changed to purple to cherry red color, because phenol red is a pH indicator. Which passaging is positive? We didn't find anything, is that right? We didn't find anything positive in the lab. Theoretically, Proteus vulgaris is positive. How about our lab results? No positive. I could ask you, how about our lab results? What are the theoretical results? Is that right? That's what we compare that in our lab situation. We didn't get anything. Okay, that's urea test. Now, urea test specifically in the clinical area for testing which bacteria? Helicobacter pylori. Or we just say HP. It's for stomach pathogen. Is that right? Because they're very low pH, and ammonia can buffer in the pH. So that's a urea test. What are the second test we do? In the same day. It's called 3-tube fermentation test. So what are the 3 tubes? Do you remember? So we get 3 tubes. They contain the sugar, which is glucose lactose, and sucrose. And then, how do we know they are gas generated? Because inside we had a Duran tube. And if Duran tube has a gas bubble on the top, we say it's gas fermentation positive. Then how do we know everything is lactose fermentation positive? Because we see they'll change to yellow color. The reason is we had a phenol red as a pH indication. And phenol red at low pH here is yellow. At high pH here, it is basically cherry red. So that's a fermentation test tube. Which one is positive? And remember E. coli is gas fermentation positive and acid fermentation positive. That's what we find. Okay. What else we did? What's the other test we have? So catalase test. So how we did a catalase test? Catalase test is basically is H2O2. If bacteria has a catalase, they will become oxygen and water. And how we did that? There are two methods we can do. In the agar plates, we could pour H2O2 to see bubbling. All we did is on the glass slides, we dump in H2O2. So why catalase test is important? Because it's differentiate Streptococcus and the Staphylococcus. Remember? So this Streptococcus is negative, Staphylococcus is positive. But I also say the catalase test should never done on blood agar. So that is catalase test. We did a clinical lab for that, okay? Number 4, oxidase test. How we did that? Oxidase test. We split them onto two. On one side, we using E. coli. On the other side, we are adding Citrobacter. And what we found is after they grow, we are pouring the reagent. It's a little bit of purple color. We call it oxidase reagent. We go there, okay? So we call oxidase reagent. And what's the results looks like? It looks like a blue, a little bit blue, a little bit purple. So that's it is positive. Now which bacteria? I said Citrobacter. Ideally should be, we didn't see very obvious. But we can assume Citrobacter is positive in our results. But more important, what is oxidase test for? They'll differentiate Pseudomonas versus a group of bacteria called Enterococcus. bacteria ACA. This is positive and this is negative. And what's the characteristics of enterobacterial ACA? They are all gram-negative, large shape, non-facultative, and gas fermentation positive, lactose fermentation positive. So remember, that's oxidase test. And I said oxidase test you have to do within 1 minute because there is oxygen in the air. Otherwise, it's all going to be positive, which gives you false positive. So that's oxidase test. What else we have? That's called phenylalanine deaminase test. What's a phenylalanine deaminase test looks like? And we had a phenylalanine slants. And then you inoculate a bacteria there. And after inoculation, you need to add a drop of the solution on the top. That is called ferric chloride. And it turns dark green color. Now why it is? Remember, this is alanine. We add a phenyl group. We call it phenylalanine. And if you have a deaminase, this is gone. So it becomes what? Become phenylpyrrolate. Kind of disappointed. You guys are empty. Lots of you. For the 3 pictures. You should write it. You can't forget about that. That's your bonus points. You should do it. Try your best. Lots of them, it's easy for grading. I think you should be all filled up. And lots of you are empty. You shouldn't do that. Yeah, try your best to get it. It's not difficult. If you know alanine, then you know phenylalanine. Is that right? That's not a difficult. You should try your best to do it. That's phenylalanine, phenylpyrrolate. Which bacteria is positive? We didn't find a very obvious one. Our results, lab results is, you can say Na. But I tell you the Proteus bulgarius is positive. Okay, this is only a demonstration. So I could ask you what our lab results looks like. And I could also ask you Proteus bulgarius. Now, by the way, all these bacteria names will be at the top of the exam paper. You don't need to worry about the spelling. It's all going to be there. Okay? And we also respect our lab results. So the question will be, is Proteus bulgarius positive or negative? You can just answer. And then I'm also going to ask you the lab results, what it looks like. If now, you just write NAZ. Okay? We just respect our results. Okay, so that's phenylalanine test. What else we have? And remember, we had one test called the SIM test. What are they? S is sulfide. This usually is the first question, very first question in the exam. What is I? Is indo. What is M? Motility. So, how did it look like? And remember, we have a tube that looks like this, a little soft. So we are using 0.5% semi-solid agar. So first thing, how do we know motility? If the rice stay in the middle, it's no motility. Let's say like E. coli. Okay. How do you know sulfide is positive? You see it. becomes dark color, or you black color, so dark black color. And which bacteria? Citrobacter. How do you know Indo test positive? We add a reagent on the top. What's the name for that? Called KOVAC. KOVAC is KOVAC. If it's KOVAC, becomes cherry red, it is Indo positive. What is Indo looks like, by the way? Let me see if I still can remember. I may forget. So that's NH. CH. Is that right? That is Indo. So what's the whole thing then? So it's called a tryptophan. So that's why we say this is a byproduct of tryptophan. Okay, that's SIM test. Okay, moving on. We had a big one. This will be testing you. Absolutely, I can tell you. What this means. What is that? That is Indo. What is them? Motility. What is V? VP, Vocus plus K. You can just write acronym, okay? What's C? Citrate. What's the results looks like? What this study for? To compare E. coli and Enterobacter. Then what's the results looks like? Sorry, I made a mistake. That is not motility. I'll tell you one thing, about like 30% of you will write motility. That's not. I use a red pen. That's meso red. Okay, you should mark it, not motility. So what's the result looks like? Indo, positive, positive. For E. coli, negative, negative. Enterobacter, negative, negative, positive, positive. The test is easy. Okay, that's 8-7. So did we finish? We left a little bit. What we haven't done. Remember enzymatic reaction of bacteria on the three agars. What are the three agar? And remember, all those three agar, we did the same thing. We basically did the same. The left side, we all inoculated is E. coli. And on the right side, we did a little bit different. We inoculated with bacillus twice. And we also inoculated with bacillus twice. And here we did Citrobacter. What are the three agars? Skim, milk agar, starch agar, and what else? split blue agar. It's very blue, that agar. We didn't get very good results, even we extended a long time. But I can tell you, for skim milk agar, basically you see transparent zone at the bacillus. For split blue agar, ideally Citrobacter, you should see the transparent zone. And another bacteria typically is positive for lipase. Yes, Staphylococcus aureus. What are these for? Skim milk agar. That's for protease. Basically, caseinase. What is the second one? Starch for? For amylase. What is the last one for? That's for lipase. How do you know amylase is positive or negative? We need a dumping. Iodine, remember? If you see the iodine turns brownish color, it's negative because starch has not been used. If you see the iodine doesn't have any reaction, it's positive because starch is already gone. Okay? So that's number 8. So, biochemical reaction, we have 1, 2, 3, 4, 5, 6, 7, 8. The key material is already there. What else we have? 2 clinical lab. So number 1, urine test. Okay, what is the urine test we are looking for? Deep strip test. What we are looking for? 3 items indicate you have urine positive. What are they? White blood cell, red blood cell, and nitrite. Now, white blood cell basically is esterase, right? Esterase. So white blood cell, we talk about the enzyme, not really white blood cell. Second, what are the agar we're doing? We're doing Macanthi agar. We're doing blood agar. That's for qualitative test. And then we're also using neutron agar for quantitative test. What's the standards for neutron agar? Is that positive or negative? Or is that UTI? Is more than 100,000 CFU per ml. Because the loop surface is approximately 0.001 ml, that's indicating 10 to the power of 3 dilution factor. Almost no space. Okay. We have another test. What we did? Throat culture. Remember the throat culture, how we did it? We did it on the blood agar. And then the blood agar, we put it in where? A candle jar. Why are we putting a candle jar? Because it's created about 5% oxygen. We call it a microallophilic environment. And what's the results looks like, you should have a lab report. And you did a good job. I was graded all of that. It's lots of you in the whole classroom, take a pictures, and you have a staphylococcus, streptococcus. Most of you find about that. Some of you find E. coli. It's interesting about it. Okay, what are the last one? The last one, what we did, antibiotic resistant test. The last one, what we did, we put a bacteria there. How many bacteria we added? We need a standard called 0.5 McFarland standard. What's that? 10 to the 8 cells per ml. Okay, then what we did, we add a disc cell. And then we do the incubation, and we find there are transparent zones surrounded. And we use the standards: resistant, intermediate, and susceptible. That is 18, that is 12, and that is 14 ml. You don't have to remember this number. But if I have a results for you, a table, can you tell me the results? Is that positive or negative? Is that resistant or not? Or intermediate, okay? Let's say I have a penicillin, tetracycline, tiny, let's say. That's all we have, a whole blackboard. This is basically the outline of what we have. That's why I tell you, we did lots of work. Did you learn something? That's very important. And you will remember the lab after 30 years. Is that okay? That's important. So it's a good time you go back to review all these important information. We don't test your chemical structure again. Okay, we already did it in the lecture. We don't test those again. Basically, is your lab results. Your results, we respect your results, and we also tell you what's the theoretical results. So, what is the best material to review? Is your lab notebook. So you should work with your bench partner using the break time or the Tuesday come back from the holiday to work together, get some bonus points, and review the whole section. And at the very beginning of the eCampus, I had a PDF version of the book. It's a picture, it's all there. It's described in very detail. That's a good time to review. Okay? And don't forget about submit your lab notebook, the time you take in the final exam, then we are recorded. If you needed the extra points, if you don't need to, that's okay. Final exam will be total 75 points, so that's a lot. Okay, so you better prepare it. And you can see the material compared to midterm is more comprehensive. So, but this is basically the outline. If you are following what I'm saying, it should be all good. But the material will be difficult than the midterm exam. That we have to respect that. So, that's all I have. I will take a picture and put on the eCampus. So you don't have to worry about that. Okay? Very good.